A family consists of a husband, wife, and their two children. When their first son was born, the average age of the family of three people was 23. So let us write down that data here. So when the first son was born, you have husband, wife, and son 1. And let us calculate their total age. Three people are there and their average is 23. So three numbers into their average 23. So their total sum is 69. Some years later, when their second son was born, the average age of the family of four people became 24. So when their second son was born, you have husband, wife, son 1 and son 2. Now we will calculate the total sum. 4 people are there and their average is 24. So 4 into 24, their total sum is now 96. Identify the age of the eldest son at the moment when their second son was born. Now when their first son was born, the total sum is 69. And when their second son was born, the total sum of their ages is 96. And S2 is actually 0 because the second son is just born. So from 69 to 96, 96 minus 69, the total sum has increased by 27. So how did the sum increase by 27? S2 is actually equal to 0. So all these three people, husband, wife and son, the first son, all three of them should be 9 years older. So from here to here, husband will be 9 years older, wife will be 9 years older, and son 1 also will be 9 years older. So 9 plus 9 plus 9, the total sum will increase by 27. So when the second son was born, first son should be 9 years old. Hence option C, 9 is the right answer. In a zoo, there are some rabbits and pigeons. If the heads are counted, there are 100. So I'll just represent that data here. Some rabbits are there and some pigeons are there. Now if you assume that the number of rabbits to be x, then the number of pigeons will be 100 minus x. Because each animal will have one head and altogether 100 heads are there. So 100 animals are there. So x plus 100 minus x, total number of animals is 100. Now if the legs are counted, there are 300 of them. Now each rabbit will have 4 legs and each pigeon has 2 legs. The total number of legs is 300. Now assume that all the animals are pigeons. That is 100 of them, all of them are pigeons. If they are all pigeons, each pigeon will have 2 legs. So altogether 200 legs will be there. Now if you replace one pigeon with a rabbit, you will have extra 2 legs. Because you are removing one pigeon, then 2 legs less, and you are adding a rabbit, so it will be plus 4. So minus 2 plus 4, so an extra 2 legs will be there. So for each rabbit that is there, there will be extra 2 legs. Now if all of them are pigeons, there will be 200. Now actually there are 300. That is, the number of legs is 300, that is 100 more. For each rabbit you will have extra 2 legs and here you have extra 100 legs, which means that number of rabbits will be 50. Each one rabbit you will have extra 2 and for 50 rabbits you will have extra 100. So number of rabbits will be 50, total 100 animals are there, so number of pigeons also should be 50. So how many rabbits are there? There are 50 of them, that is option D. The speed of a boat in still water is 4.5 kilometers per hour. So we'll just mark it here. So B is 4.5 kilometers per hour. And the speed of the river is 1.5 kilometers per hour. So R is equal to 1.5. The boat travels a certain distance upstream in the river and then comes back to the starting point. What is its average speed for the whole journey? So initially it goes upstream. Now when it goes upstream, the speed will be B minus R. So that will be 4.5 minus 1.5. 4.5 minus 1.5, it will be 3 kilometers per hour. So that is the speed when he goes upstream and then comes back to the starting point. Now when he is downstreaming, effective velocity will be b plus r. So that will be 4.5 plus 1.5, that will be 6 kilometers per hour. What is his average speed for the whole journey? For half of the distance he travels at 3 kilometers per hour, and for the other half of the distance he travels at 6 kilometers per hour. Then average speed is given as a very popular formula, 2ab by a plus b. This is the way it's usually represented, so we'll also represent it like this. So a is the speed for one half of the distance of the journey, and b is the speed for the other half of the distance of the journey. So here a is equal to 3 and b is equal to 6. Just substitute into this formula and you will get the average speed for the full distance. So average speed is given as 2ab, where a is equal to 3 and b is equal to 6, divided by a plus b, that is 3 plus 6, 9. Here 3 divides 1 time, here 3 divides 2 times. So 2 into 2, 4 kilometers per hour. So that is the average speed for the full journey. Hence option A, 4. Two trains of lengths 200 meter and 100 meter respectively are traveling one behind the other on a railway track. They take 4 seconds and 2 seconds respectively to pass a pole. So let us calculate the speed of the first train. So let us calculate the speed of the first train. Now you have the basic formula, distance by speed gives you time. For the train to cross a pole, the distance to be moved is the length of the train. So distance is 200 meters by speed gives you time, and the time required is 4 seconds, from which you will get speed of the first train. I'll just mark it as speed 1, that is equal to 200 by 4, that is 50 meters per second. Next we'll calculate for the second train. For it to cross a pole, its own body length has to be moved. So distance to be moved is 100 meters. Distance by speed gives you time, and the time required is 2 seconds, from which you will get speed 2, that is equal to 100 by 2, that is 50 meters per second. So both of them have the same speed, that is 50 meters per second. What would be the time required for them to cross each other when they are moving in opposite directions? Now when they are moving in opposite directions, as well as when they are overtaking, the total distance to be moved is the sum of their body lengths. So total distance to be moved is 200 plus 100, and when they are moving in opposite directions, relative velocity will be 50 plus 50, that is sum of their speeds. So total time required will be 200 plus 100, 300, divided by 100, so altogether 3 seconds. So time required is option C, 3 seconds. A number is increased by 30% and then decreased by 30%. Find the increase or decrease percentage. So we will assume that originally that number is equal to 100. We can assume 100 because calculating percentages with 100 is very easy. Now it is originally increased by 30%. So the new number will be 100 into 130 by 100. So new number is 130. You have increased it by 30%, it has become 130. And then it has been decreased by 30%. So 130 has been decreased by 30%. So now you will have only 70% of this because it has been decreased by 30%. So you have only 70% of this. So this you will get it as 91. So originally it was 100 and now it has become 91. So effectively there is a 9% decrease. So effectively there's a 9% decrease. 100 to 91, it has decreased by 9%. Hence option A, 9% is the right answer.